Okay, we're going to teach you how to create something that you can use in a hands-on fashion to help you learn. What we're going to focus here is using a syringe to learn our lung volumes and our lung capacities. We'll get our pointer out. So what you're going to need here is some supplies. Use syringe is good. You can use any size. Going to need some sort of safety pin or a paper clip that you can sharpen up, or some piece of wire that's thick enough, or somewhere about the size of a safety pin. A pair of pliers to hold those, and a flame. Now, what we're going to do is figure out the volumes. Now we need to set the ratios. We need a 6 to 6 to 4 to 6 volume. In this demo here, I have a 35 milliliter syringe. So what I did is just mark off on the syringe 6, and then an additional 6 takes us to 12, 4 takes us to 16, and then another 6 takes us to 22. You can expand those out. You could double those if you wanted, and take you down somewhere to 44. Now, maybe you can't do that, or 1.5, so 9, 18 plus 6, 22 plus 9, 31 to use up more of the syringe. But whatever it is, figure those out, calculate where the lines need to go, and then you draw those lines in a permanent marker. So I've got the 4 lines set and ready to go. Now what this syringe is going to do is going to create or be our lung. So what we need to do first is establish the residual volume as low as or small as the lung volume can go. So we take that safety pin, we heat it up, and we're going to put it through our 5 lines. So you have something here. If you've got it heated up, it goes through pretty easy. Here's the safety pin, kind of looking at it from the top. You're going to try to go a little off center because you want to be able to close the safety pin and not hurt yourself. If you put it through the center, you won't be able to close the safety pin. We've also done them with nails or wire or whatever, but safety pin is probably the safest. So the instructions here, you're going to heat the tip right here. You're going to align, make sure you've got things where they need to be, push them through, and then you're going to close the pin. This didn't get hot enough for me to worry about with a plier, but if you're heating up for any length of time, you're going to need a pair of pliers to hold those without burning your hand. So what we have here is now we've established the 4 lung volumes here. And then each step we use, the first is our inspiratory reserve. The next is our tidal volume, our expiratory reserve capacity, and then there's our residual volume. That's as little as the lungs can go. With this model, we're using the plunger here as the diaphragm. It does most of the work with our lungs, moving things up and down in our thoracic cavity. So we're going to use that plunger to represent the diaphragm moving up and down, changing our lung volume. The inside of the lung is volume is here at any given time. You've got your trachea, your bronchi going up out the top. So we have our diaphragm as far down as it can go, our lungs expanded as big as they can go, and then we work step by step to as small as the lungs go. We get to a point where we can't bring up the diaphragm anymore. We've hit the pin. We can't collapse the ribs anymore. We've achieved the lowest volume we can with the lungs. So if we start to do the representations here, an adult cow, the residual volume, 6 liters, expiratory reserve, 6 liters, tidal volume, 4 liters, inspiratory reserve, 6 liters. So, or you can think about gallon and a half, gallon and a half, gallon, gallon and a half. That's good enough. And they line up on our syringes this way. So, right now here we've got as much volume as our lung model can hold. That's got all 4 volumes in it. So that means it's our total lung capacity. You can hear if you start to mark those on the outside there, where our lung volumes are. You can see we got our 4 lung volumes from our dead spot or our minimum in our lung back to our maximum. That's our vital capacity. We have our fractional reserve, functional reserve, and then you've got your inspiratory capacity here, and then the total lung volume, as much as we can hold in the lungs, all 4 volumes together, is the from the first mark here all the way to the top. So we move the diaphragm up, we move through in a stepwise fashion. We have in this case, we're using our total vital capacity. We're breathing in, breathing out as much as we can, and that cycle goes through. So the diaphragm moves up, step, step, and then we go the other way. We're moving through the vital capacity, opening it back up. So vital capacity is the air we can exchange in and out of the lungs. Again, our residual volume, we can't get rid of that air because that's as small as the rib cage can be. That's as high as the diaphragm can go up. Normal breathing, the diaphragm is moving from here to here. So here to here, back and forth, back and forth. This doesn't change. This remains in the lungs. This remains in the lungs. The tidal volume is at 4-liter gallon change of air that a cow normally moves in and out of her lungs. She's got reserve going up, she's got reserve going down. If we get that running around when they get loose in the spring, you're going to use all your reserve capacity. So your diaphragm's going to work extra hard, the ribs are going to move in and out. We're going to move up, down, up, down. We're going to go through those 3 volumes, push those all out of the lungs through the trachea. Then we're going to draw them all back in. We're trying to exchange as much oxygen as we can. We want to exchange more volume if we can. We always have this residual volume. That's a function of all the dead spaces, the bronchi, the trachea, the mouth, nose. Those are air that don't get changed. And then also we collapse our lungs as much as we can, our ribs as much as we can. We bring up the diaphragm as much as we can. A cow's only going to get down to 1 gallon of lung capacity. Okay, so just some quick notes here that since this mimics the actual lung, it's important to note that while we have these capacities and these lung volumes, you can never achieve them in the lungs by themselves. They're always with something else. Like if we look at vital capacity, inspiratory reserve, tidal volume, expiratory reserve. These 3 right here, they can never be in the lungs by themselves. They are the movement of the diaphragm and the ribs, the minimum and maximum volume we can. The residual volume is always going to be there. Same token, you can never have the inspiratory capacity down here by itself. If you've got those volumes full, you also have these two. So you're figuring out vital capacity, inspiratory capacity by difference when you're doing it. You can never measure that by itself. And as you can imagine, because of the way things work, you can never have the inspiratory reserve, the tidal volume, or the expiratory reserve volume by themselves.